Welcome to this sixth ASHVIN podcast series presenting innovation stories of our partners. I am Natalia Sediel, Marketing Manager at Australo, the partner running the communication of the project, and your host today. ASHVIN is an innovation and research project supported by the European Commission's Horizon 2020 program. It develops a novel system based on digital twin technologies, which aims to foster safety and productivity of the European construction sector. ASHVIN runs for 3.5 years and it gathers a group of 15 partners, including universities, SMEs, industry partners, all experts in digital transformation of the construction sector. This mini podcast series presents innovations resulting from ASHVIN's technical work packages. We want to share with you our partners' perspectives and show how ASHVIN is working towards the construction industry of tomorrow with novel digital twin solutions that respect the European policies, values, and regulations. Today, we're talking about how to develop various high-quality conceptual design options effectively with Joan Evelyn Ongodia. Joan is a research assistant at the Civil Engineering System Department of the Technical University of Berlin. She works on early-stage design parametric modeling and generative design optimization for construction projects. So it is very nice to have you with us today. Joan, thank you.
Thank you, Natalia.
Could you please introduce yourself and your main role in the project?
My name is Joan Evelyn Ongodia. On the ASHVIN project, I'm the task leader for task 2.3. Task 2.3, we're looking at the early stage of design, and in there we're developing parametric models and doing generative design optimization. Yes, that is my role on the ASHVIN project.
Fantastic. Which is a specific challenge that your innovation addresses?
Well, specifically, my innovation is addressing the challenge of missing data or insufficient data at early stages of construction projects. Usually at the early stages of construction projects, we don't have data. And so what we do in the ASHVIN project, in my task 2.3 is connected to the preceding task 2.2. In 2.2, we use historic data from past construction projects to put this together. And then I'm able to import this in the generative design configurator, which is what we're discussing today. And in this way, we are then able to use this past data or historic data, if you may prefer to call it that way, to then use it as data in this early stage design. In that way, you don't then need to spend so much money trying to get data, or you actually don't have the data yet at this early stage of design. Pre-feasibility studies, for example, when they're done, you don't really have all the data. So this way, you're able to actually get this data substantiated in that way. So basically, because you're also using data from past projects that are working, that have been successful, that way we are then able to increase accuracy in design at the early stages. And also because of that, we're able then to ensure high quality conceptual designs. And this is really important because from this early stage design conceptualizations, it's really important that you have a high quality and accurate design that will really impact your project success in general. So those are the two challenges we're solving here: accuracy, high quality designs, and also improvising for missing or insufficient data. Thank you.
Great. And could you please walk us through that innovation and how do you think your contribution can improve the construction sector of tomorrow?
Okay, so basically, generally, when you have a project that you have to develop an early stage design for, when you're using the Gen tool, you would need to have a knowledge base, a knowledge database. In our case, in the ASHVIN project, we call this the evidence-based design knowledge base. So that comes from task 2.2. I'm sure you must have listened to that podcast before on 2.2. If you didn't, I would recommend you listen to it. But basically what really happens there is that we collect this data, historic data from past construction projects, and this is what we import into the software. for the Gen tool. In our case, we use Dynamo, but you can use Grasshopper and other software that is suitable to your project needs or to your industry. So we import these inputs. For example, the length. For example, if you say a footbridge, the key things you're looking at is what are the common ranges for the length, what are the common ranges for the width, what are the common ranges for the thickness, basically the geometry extents. And then we import that, and this helps us to develop a parametric model, our initial parametric model. This initial parametric model already can be a one solution that you give to your client. But when you need to actually give your client at least a myriad of options, maybe say 3 options or so, for them to really look at and rationalize and decide on the best option, then that is now when we use the relationships from this knowledge base again. These relationships are basically, for example, say for given X to Y length of bridges, the project cost maybe say Y million euros. So with these kind of relationships, you're then able to do the optimization and then see in terms of your predictions, which kind of designs can you come up with that would be logical and that would fit within this. In a way, this also then helps to give you like intelligence into what your construction performance will be like when you to develop this project. And then what we really do in the end is that we present these solutions on a Pareto at the Pareto that are at the Pareto optimal front. It's basically an XY chart, really an XY scatter chart, and then we're able to really show our client these are the options. But to even make it better in ASHVIN, because we're talking about digitization and digital twin, is that we then go a step further. We actually then use the 4DVD tool, and in this 4DVD tool, it's very interactive. So it's basically to help visualize. Like, for example, you're not just looking at it in a 2D space, but in a 3D space. And beyond the 3D space, we call it a 4D space, because we then try to really put in, for example, a crane moving these parts of the bridge and all that. So in a way, it's really engineering at its best for the future, because we're then getting away from the 2D, going a little beyond the 3D where we application and things like this. So with a 4DVD tool, the visualization is really good. Think of it like a game, or how people are doing the gaming design or gaming engines. So basically it's more interactive. And in this way, we really see our solution as very novel, and not just for this decade, but for centuries to come. It's really a futuristic solution.
That's fantastic. Thank you very much, Joan, for being today with us, and hear you soon. Remember that you have the opportunity to benefit from these innovations with the Win ASHVIN initiative. We are onboarding only 50 European projects on our platform to provide a first-hand experience with digital twins in the construction industry, completely free of charge. Are you interested? Write us an email. Thank you for listening. I hope that this episode gave you new ideas about how new technologies can play a role in addressing the challenges that we face in the construction sector. Hear you soon. Bye.